Hello everyone, welcome back. So this time we're talking about the concept of a centroid. We kind of hit on this just for a second last time before I was like, you know what? You've gone long enough. Let's break it up. Okay, so what is the centroid? Well, the centroid is the geometric center of an object. Now, the centroid will coincide with the center of mass or the center of gravity only if the material of the body is homogeneous. It means the density or specific weight is constant throughout the body. Also, if the object has some sort of axis of symmetry, then the centroid always lies on that axis. So you see right here, we have a half circle. Axis of symmetry is down the center, and so the centroid is along that axis. And there you go. There you have it. That is the centroid. Now, luckily for you, you don't have to worry about calculating the centroid. You can, in fact, just look it up. It's in your textbook, actually. Look at the centroid for different shapes right here, or even three-dimensional shapes. So use that to help yourself. Okay. Now, in some cases, the centroid may not be on the object. Think about like a hollow cylinder. The centroid would be floating in the middle. Or a ring. The centroid is still in the center because it's a circle, but it's floating in the middle. Okay, how do you determine the centroid of an area? Let's just go ahead and get all these here. And in all honesty, it's pretty much the exact same as if you're trying to find the center of mass or the center of gravity. So that makes it very, very simple. You break everything up into a bunch of shapes which you know the centroid of, which are a bunch of rectangles, and then you just weight those all by their area. So the centroid is more or less the center of area for a 2D object, or the center of volume for a three-dimensional object. We could use those exact same equations we saw earlier. Okay. So if you have some sort of equation for a shape, for example, if I have, this one says y equals x squared plus 1. So here we go, x squared plus 1. I've got this line right here. It's not really easy to break that up. And so what I have to do is I have to figure out some sort of differential element. I have to break this up into rectangles. I can do it this way if I want to, or I can do it this way. Okay? I can do it vertically or horizontally. I can even do it at a diagonal, but don't do that. That's an absolutely terrible idea. Vertical or horizontal. Okay? What it says is if y is easily expressed in terms of x, use a vertical rectangular element. Otherwise, use a horizontal one. You'll figure that out pretty quickly. Okay, now you got to figure out what the area of this element is. So you're going to have a value y, okay, and you'll have some distance that goes along. You'll be able to get the area of this. And you determine the coordinates of its centroid, which sometimes is very easy. At least in the y direction, that's very easy. It's just half of the height. The x direction, also fairly easy, but we know what the distance is. It gets harder once we get higher up. In this case, I would have used a vertical element, because this is going to be a nightmare when I get to like right here. So a vertical element would have been better. So with that, you'll figure out where the centroid of each of these individual shapes is. And then you're going to integrate them. Okay? You're going to have a sum, which is going to turn into an integral in this case. An integral of y hat times the area, dA, all over integral dA. And that will tell you where the centroid of this shape is, whatever the shape is. And we do the same thing for the x-axis. Okay, now this is one of those things that, like so many times, you have to see it done before it really makes sense. So next time we're going to go over some examples to work through this together and help you figure out how to do this. Well, I hope this helps you, and next time I'll jump into an example. See you then. Bye-bye.